So it is December 25, 6:21 a.m. in the morning. So let's make a review of what we have learned about why we should use the PyTorch. Okay, why we should use the PyTorch when it comes to deep learning. So this lesson explains why PyTorch became one of the most popular deep learning frameworks, especially for students, researchers, and beginners. So PyTorch feels like a normal Python, right? It's kind of like some of the researchers and the students and the developers of the models intended to use the PyTorch because if it's used simplicity, right? It's like having a basic operations like adding two numbers look exactly like regular code rather than uh, how we use the deep learning way before, right? Like it's kind of uh, uh, it's kind of so hard to build a structured model to debug it and to optimize it because once the model was structured, uh, you're going to restructure it again to be able to fix those things or to debug the model that you have built. But in the PyTorch, by using the PyTorch frameworks, um, it feels like you're going to you're just doing the normal Python. It's like a Pythonic, right? So PyTorch uses tensors to store numbers, but they behave in a very intuitive way. You can print values directly and immediately see results. It's like a normal Python variable. So the key idea is deep learning in Python doesn't feel special or complicated. It feels like writing standard Python. So the second thing is the traditional programming versus the machine learning. The lesson highlights a key difference. So in the traditional programming, you write explicit rules, and this happens. Do that. In machine learning, you give examples of inputs and outputs, and the system learns the rules. Like for example, writing thousands of rules for a recommended system is impractical, right? You're going to put a lot of if statements and a lot of bunch of codes to be able to for machines to give you some of particular output. But in the machine learning, you're just going to give an inputs and guide the model to what is right and wrong, and the machine is just literally um, learn something from the input data that you have learned with your guidance. And it's kind of guidance, and sometimes it's not because it's learns by predicting some values, adjusting if weights and biases. So why early deep learning tools were hard? Because the early deep learning focused heavily on performance and math efficiency, which led to extremely complex code for simple tasks, hard to read outputs, poor debugging experiences, like what I said before. So the early deep learning frameworks focused heavily on performance and math efficiency, which means there's a lot of computational things that we're going to do when it comes to deep learning, which could lead to extremely complex code for simple tasks, hard to read outputs, poor debug experiences, and yeah, and they relied on static computational graphs, where all steps had to be defined in advance. You couldn't easily change or experiment with the way normal Python loops, conditionals, and debugging tools didn't work. Errors pointed to internal framework code, not your own code. This makes this experimentation slow and frustrating. So number four is PyTorch breakthrough dynamic computations. Here's the PyTorch. Way before, uh, we relied on static computational, but now we're going to have dynamic computation, which means PyTorch introduced dynamic computational graphs, which means the graph is built as the code runs. You can use normal Python if statements and loops, can modify code anytime, like you're going to just uh, uh, doing some simple programming things if you have experience in programming, especially in Python, so very easy to use. Error responds directly to your code. Debugging feels natural and familiar. So PyTorch lets you experiment freely without fighting the framework. And strong community ecosystem, because PyTorch is more than just a tool. It's back for a large of global community, widely used research in industry, right? Tons of shared models, tutorials, and solutions, and easy to find help for almost any problem. So, why to learn PyTorch? It's a beginner friendly, supports cutting edge of AI research, encourages experimentation, skills from simple demos to large real world problems. Whether you go learning, research, and career growth, PyTorch provides a smooth, powerful entry to the learning. So, the final takeaway is PyTorch succeeded because it removed unnecessary complexity from the deep learning. By making neural network code feel like a normal Python, it allowed people focus on ideas, experiments, and learning rather than struggling with tools. And that's it for the uh, uh, from the course. Why we choose PyTorch as a framework in the deep learning.